Hi everyone, I'm Pranoti, host of Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials or nanoscience, who tweets from the Real Scientists Nano Twitter account, which is realsci_nano. Hi everyone, my name is Pranoti. I am your host of Under the Microscope podcast, and today we have with us Stephanie Gallant, who is a postdoctoral research fellow at the University of Montreal in Canada. And I hope I pronounced her name correctly, and I did? Okay, good. Excellent. Hi, Steph. How are you?
Hi, good. How are you?
I'm good, excited to talk about your science because it sounds really, really cool. So let's dig in. Tell us about your research, please, in super simple words.
So, I'm a materials chemist by trade, and I mainly work in vibrational spectroscopy, and more specifically, Raman spectroscopy. And what spectroscopy is, for those that might not know, it just means that we use light to study materials, their structures, their properties, how they behave in, maybe different environments. And there's many purposes to using spectroscopy. My work has been in looking into what are called plasmonic materials to create new sensors, better sensors for different applications.
Okay, so new sensors, better sensors for phones, electric cars.
Yeah, it can be any of those things. My focus has been, I've kind of done two different things. So my PhD, I was developing new two-dimensional sensors, so kind of just flat sensors to use with a standard Raman spectroscopy setup. So it's like you use it on a microscope stage. So just flat sensors and combining different materials. So my PhD work was looking at environmental sensors. So we were interested in being able to detect small amounts of hydrocarbons in water, either for monitoring in places where oil is extracted, or even bodies of water, drinking water. And so that was kind of the focus. So again, very practical work. It has a specific real world goal. And so that's what I did during my PhD. Now that I'm in my new role as a postdoc, we're looking at, it's the same type of technology, but we're actually creating nanofibers for the same type of sensing, but we're actually looking at biomarkers. And so it's more on the medical side of sensing. And so I know my research group, I'm still pretty early on in my projects, but some previous work has been in detecting brain biomarkers of, say, Alzheimer's, Parkinson's. My group has also done some stuff looking at blood. And so it's something called SPR, which is surface plasmon resonance, similar to what I just said, plasmonic materials. And the idea is it's kind of like a microfluidic setup as part of what we do as well. So you can use a very small amount of blood or serum or another biological fluid and test for specific markers if you're looking for, a marker of a certain disease or other health monitoring.
Okay, so if just to oversimplify it, to dumb it down, because this is a completely new thing for me. If
Sure,
I have and they take my blood, I actually have a blood appointment. I call them vampires because I don't like people taking my blood.
I'm not a fan either. I get it. Yeah.
I have that appointment in 2 days from now. So to understand your research, once that blood is taken, if I say, hey, can you check for Alzheimer's or XYZ marker, then the sensors that you're working on, those will be injected in the blood, and then they will attach to whatever Alzheimer's or XYZ sort of a thing. And then once we do Raman spectroscopy, then those spots will just not glow, but there would be a peak.
Yeah, exactly. Yeah. So the idea is, again, there's different ways of sensing it. So the SPR, the little microfluidic setup, that uses also two-dimensional sensors, which is what my previous work was in, and that you basically create an environment, like you said, it's all about binding, it's surface chemistry. So you have to plan, if you're looking for a specific biomarker can be found in blood, you have to think about, okay, what antibody can attach to that? Do we need a secondary antibody to attach to the top of it? It's you have to know your chemistry, and it is overall, all of this is surface chemistry. and you're planning to grab what you want and ignore the rest of the stuff. And of course, blood has so many different compounds, molecules in it. So that's part of the challenge. So I'm very new to this medical side of it. So I've had to learn a lot of this as well, because I've been very much a physical inorganic chemist before this. And now I'm moving into the biochemistry. But that's the basis of all these sensors. So there's different ways to design it. You have your flat 2D ones. Like I said, we're also working on fibers, which can be inserted into cells and stuff. And so it's basically a very, very thin, it almost looks like a needle tip. It's made of glass though. And so we do some surface chemistry additions, and we make sure that our active plasmonic material, and I haven't explained actually, plasmonic just means it's usually a metal, something that has lots of free surface electrons. And when we hit it with light, which is energy, they kind of oscillate. So the electrons are free to move, and they enhance a local electromagnetic field, which helps increase the signal that we get for our spectroscopy. So it just means basically we get more information in, and there's more success for especially those really dilute molecules, if we're really looking for a little bit of something. So that's where this word plasmonic comes into it. It's a specialized type of Raman.
Okay.
Yeah.
Wow, that sounds so cool. Oh my God,
It's pretty cool.
It is so cool. It's so cool. There is so much to unpack there, not just the harmonics part of it, but also that you mentioned that you are kind of transitioning. You have entered a new world with the life sciences part of material science as well, which is something I love about material science, that it's so broad.
Yeah, it's great. It's definitely tough when you're in a period like right now. It's a big learning curve, but it's so cool that I can apply the same background knowledge and theory and everything across all these other fields. It's very cool.
That is so cool. So Steph, what can the followers expect in the week that you will be tweeting from the Real Scientist Nano Twitter account?
So I'll try to keep it all across the board, split it up by some days. So I'll give a bit of background about who I am, my background, my education, other things outside of science that I like. I think to be a good scientist, it's important to also be able to step away, turn your brain off from the science stuff, and do. So I have many hobbies that keep me on my toes. So I'll start off with that. Then maybe Tuesday, Wednesday, middle of the week, I'll go into my actual research background. So aside from my formal education, where my research is, how it started, the different progression of projects, and my experience, through undergrad, going on to graduate school. And then after that, I'll talk a bit more, finish up talking about the research if there's anything left. Also talk about something where not all scientists necessarily have experience with it, but we actually, one of the sensors I developed is currently in a patent application process. So we're somewhere towards the end, which is really cool. And so for me, that was another huge learning curve of all the legal parts of science, which I totally had, no idea before this. So I think it would be interesting maybe to talk a bit about that, some publications, of course, and then talk about the end of my PhD, which is still pretty fresh. It's only a few months ago. And then, end of the week, Friday, probably talk about a little bit more about my new position, which I was just telling you some of the research, and beyond that, future plans, what comes after that. And so kind of a broad range of where I started really early on to literally today, or the day that I'm posting.
That is amazing. I hope the patent application goes through. I think it's a bit too optimistic to expect that it will happen while you are before you are.
That would be amazing. Maybe the good thoughts, the fingers crossed, will make it happen.
Definitely. I definitely keep my fingers crossed. So it sounds like a super exciting week. Really, really looking forward to having you on Real Scientist Nano. Steph, thank you very much for speaking with me.
Thanks so much.
Thank you for listening. I also want to thank my team, Johanna, who is our news editor and curator liaison, Swenya, who is our podcast engineer and curator liaison, Lucia, who is our media and website coordinator, and myself, Pranoti, being the owner of the Science Talk and host of Under the Microscope. To know more about us, visit our website, thesciencetalk.com, and follow us on Twitter at realsci_nano.